Good afternoon to all of you joining us today in Timber Design Society's third webinar of Series 2022. My name is Namir Amsu, member of the Timber Design Society Management Committee. TDS would like to extend its thanks and appreciation to the team at Engineering New Zealand. This webinar is kindly sponsored by the following organizations. TDS Committee expresses its thanks and appreciation to these sponsors: Exlam, Simpson Strong Tie, MyTech, and Future Build LVR. We welcome TDS members, CSOC, and EGP members, and any students joining us today. Today is TDS third webinar series in 2022 by Damian Otto, talking about mass timber opportunities, constraints, and consequences from a product development perspective. Damian Otto, a little bit about Damian. Damian Otto has 20 years of self-driven professional experience and specialized knowledge across architecture, construction, development, and off-site manufacturing, including product design and development, design management, and entrepreneurship. Damian, please. Thank you very much.
Yeah, hi, good afternoon, everybody. Thank you, Namir, for the introduction, and Bernie for setting this up, and hello to everybody on the call. I'm sure a lot of us have met before, so some of what I'm about to talk about will be familiar, and hopefully some of it will be unfamiliar and useful to you. So, and again, thanks to the sponsors for today's talk. So look, I'm going to take you through a presentation, and I guess the main reason for this is to talk about mass timber, of course, and the title very thought about choosing the title and the talk from my experience over the last few years with the Lend-Lease is the opportunities, constraints, and consequences. So it's all about looking for the use of mass timber, but also the things that we need to keep a lookout for in terms of when we're using that in projects. So why mass timber? So mass timber construction demand is growing globally. It's no surprise. I think New Zealand has been on the forefront of this, and certainly in the work that we're involved with overseas, a lot of shared knowledge, a lot of shared interests, and also shared learnings across a range of different regions around the world. So just the contents for today, a little bit of experience, although I won't go over that too much. Then contextualizing what is product development. We'll look at the products themselves. We'll look at some systems and projects, application. We'll look at some constraints and consequences, and then some round up around talking about design for manufacturing, assembly, and disassembly, and the possibilities thereof. So as Namir mentioned, my background's in architecture, and last 20 years or so has been quite varied in experience. You can see the grounds down there, which was completed a few years ago with Dr. Michael Newcomb and Petal Thorpe, and a range of sort of prototyping exhibitions and lots of other work that's gone on in the last 10 or so years. Probably most notably in New Zealand was with Tall Wood, and we piloted a few projects there, but I could talk about that a bit later on. Right now, I'm a full-time contractor with Lend-Lease's Kit Parts team, so operating the team out of Sydney, California, and Milan. We work on a range of projects and products, particularly the Google residential product or residential programs. This is a joint development venture with Google itself in Silicon Valley, with the idea of constructing 22,000 apartments over the next 10 years, a lot of which will be mass timber buildings. So we're dealing with the CPC code over there, the Type 4 A, B, and C buildings. And then also a little bit of work in Milan as well, which is the Mind project, which is the transformation of the former Expo site into a live-work community. So both of those sites are heavily reliant on both offsite manufacturing generally, as well as mass timber products and a whole other range of products as well. So the team that I work in, about 13 product developers, engineers, architects, industrial designers, all working together to create a kit of parts to basically roll out at scale for these projects. And so basically what we do is product development. So what is product development? Now, product development as a discipline is very common in software and tech and manufacturing, but not so much in architecture and engineering and construction, which probably needs to happen more. We need to get more into a product development mindset in our industry. But effectively, product development is trying to understand problems in our industry, develop a hypothesis around what we might be able to counter those problems, and then effectively collaborate and then bring that to market. And in fact, in the team I work on has just brought a range of timber connectors to market, which you should be hearing about a little bit soon. That was with Lend-Lease's partners, Home Solutions, based out of Christchurch. So look, I think there's no surprise. You see this spaghetti diagram on the right. Our industry in New Zealand and globally is thoroughly ripe for disruption. So not just about mass timber, but about the entire building system, of which mass timber is a very fundamental part. But everywhere you look in the contractual chain, in the relationship chain, in the supply chain, there are opportunities for innovation, and that's really what product development is about in this industry. So just to kind of put this, the 4 basic steps is the first step when you do product development is you uncover and understand the pain points of your clients. And I'm sure we could all list a number of pain points that we go through on a daily basis. Never mind our clients, never mind the end users, and never mind society, which ends up with these buildings that we create. So we do things like labor and activity analysis. We look at code and practice. We look at materials and manufacturing, supply chain logistics, and most importantly, putting the client and the end user experience as the key data point that we need to consider when we're doing product development. The next thing we do is we'll create a hypothesis based upon stage 1 to test. So most of the time, what we're looking for is to reduce complexity. We're looking for function doubling, so making something do more than one thing. We're looking to reduce activities on site, which therefore reduces labor. We're looking to shift labor, shifting labor not necessarily just off site, but shifting labor from some kind of trade to another kind of trade to look for a delta. We're looking for health and safety increases, and we're also looking for new processes and materials. The third thing we do is test through collaboration, and this is design and prototyping, so virtual and physical prototyping, time and motion testing, simulation, of course, working with supply chain, and then we're looking for feedback loops. We're looking for a go or no go at that point, because the next stage is to integrate that product into a project and bring it to market. So the reason I'm talking about this is I want to make a distinction between traditional design process, the typical serial, linear, milestone-driven design process when it comes to buildings, and then a fundamental rethink which product development allows you to do. I know there's a lot of expertise on the call, so I'm not going to go too much into the product itself. But for those who are new to mass timber or still getting their heads around it, the first thing we need to understand with mass timber and all products is that they basically made of 3 parts. There's a digital product, there's a physical product, and then there's the process to bind those two things together. And so we can think of the physical product being the CLT or the glue lam. The digital product is the design information that supports the creation of that product. And then there's the process of weaving those two things together. And basically my view is that process is basically not even thought about as an area of innovation. So what I'm trying to do is bring process to the front of how we innovate and how we are able to get the best out of the digital and the physical. So when we talk about the physical product, we're talking about three broad categories. We're talking about LVL, glulam, and CLT. Of course, there are other sort of sub products, I guess you could say, like nail laminated timber. But effectively, these are the kind of the three basic building blocks we have. In New Zealand, LVL is probably used far more than glulam. Offshore, where we typically work, glulam is used like, completely inversely proportionate to LVL. But these are the basic building blocks that we work with. Also with obviously steel and concrete that's used, the connection fixings, the linings, the treatments, and the processing, the CNC processing and other post-production processes. So why is there a global race to solve for mass timber systems? Everybody that we are in contact with, everybody in our team is working, is effectively what I think is in a race to solve for mass timber against the basically BAU, business as usual, which is typically in California, it's typically concrete. In other places, there are other kind of systems, but there is a huge investment going into trying to crack the code for mass timber systems. And there's a bunch of reasons why we would do that. Three just right there, 20% of the weight. So we look for, savings of foundations, carbon emissions, of course, absolutely massive. And then I guess the fact that it's a renewable resource. There are a bunch of other factors that we're interested in that are less measurable, such as biophilic value. But ultimately, there's so much incentive right now to solve for this particular kind of product to be able to ramp up at scale. You're seeing CLT producers and providers increase their number, increase production to try and keep up with demand, which is effectively doubling every 4 years. In New Zealand, we have access to all of the main suppliers of the products that we need to create the buildings we want to do, which is fantastic. And also in New Zealand, we don't have the kind of common perception or common need to sell the idea of timber to the client. We are a timber nation, so therefore we've removed at least one of those barriers for uptake. And obviously, there's a number of buildings produced over the last 10, 15 years that have been effectively pilot projects, but effectively trying to test and trying to find the right combination of products, right combination of structure and other things to try and crack that code. We haven't quite got there yet. There are also some common misconceptions that I think are hold us up a little bit. One is probably very New Zealand centric is moisture. Now, there's a lot of fear and doubt and uncertainty around the treatment of moisture or moisture getting into CLT, which you simply don't find in other jurisdictions, but to the same level. And that's not because they've got different weather over there. Sometimes they do, but effectively, in a lot of jurisdictions, the idea of moisture is moisture protection of CLT is somewhat down the list of concerns because there are other concerns that we need to look at. And probably the key concern right now that we're dealing with is acoustic performance. We get that nice relationship between span, thickness of CLT, vibration, and acoustic performance, which becomes quite an interesting feedback loop to try and resolve. One thing we do find is that policy in the States, where we mostly deal with, is really driving towards exposure of CLT on a ceiling in a residential context, which means that you're shifting everything to the top of the board. But obviously what you have to then do is deal with the underside of the board with respect to fire, because there's still a 2-hour fire requirement in the States for main structure. And then there are other benefits too, softer benefits like noise reduction. I was lucky enough to visit a retirement village in Austria, and the architect there told us that one of the main reasons that offsite manufacturing with CLT was used was due to the fact that it was a noiseless or far quieter construction and far less impact on neighbours, which is something that we probably don't care that much about in New Zealand. But you kind of sort of see those directions coming in. Labour reduction, time reduction, those are pretty well understood, provided that you get your design and your product strategy right. There are also industry and policy drivers. Again, no surprises here. We are living in cities and in countries that have made commitments to climate change. There is a C40 cities organization, of which Auckland is one. C40 cities is now something like C97, and basically they represent a quarter of the global, or a quarter of GDP. But effectively, the cities themselves are committing to policies that the market has not yet provided. So we need to, as an industry, create the solutions that our cities and our society can take up and start to use. And mass timber is critical for that. Yeah, look, I'm not going to talk too much about global growth, where we are all aware that every day you can find a new mass timber building going up somewhere. Demand is not slowing down, and it's happening everywhere. So it's not just in the States, it's not just in Canada, it's across Europe and even into Asia as well. And I think probably we're at a bit of a tipping point right now. So I kind of look at the idea of electric vehicles as a bit of a parallel to mass timber buildings. There's the technology has been there for car batteries even before petrol was around, but there's a tipping point that we go through in which there's an acceleration of growth. And I think really the tipping point I find is with mass timber is that when product and process match up together, and supply is there to back it, then you start to get an acceleration of uptake, or at least that's the hypothesis. Coupled with the policy shift that's going on, coupled with the general kind of media and public interest around mass timber, I think it's a recipe for far more buildings to come. And then probably just a cautionary note is that mass timber is only part of the answer. When we're looking at affordable housing or affordable buildings, we are dealing, when we're talking about timber, we are dealing with a small proportion of the overall cost. So the diagrams on the right are basically a relative proportion of cost, a relative proportion of spend during the lifetime for a multi-residential apartment building. So the contention here is that, like, if we make a 10% saving on structure costs, for example, we're only really bending the needle by 1.5% of the overall cost, which is not to be sneezed at. But then if you look at the building services, in this case, it's a fully ventilated building and conditioned building, you make a 10% saving in the proportion of costs. You get a 2.5% saving, but more importantly, if you look at the cost around energy in use, it vastly outweighs the cost that you'd normally spend on structure during the life of the building. Which is to say that mass timber, from a product development perspective, is really about what it enables and what it allows for in the building rather than the product itself. We have looked at a number of different systems and projects, which we'll go into in a second. And really, the systems and projects that are available and have been tested and piloted around the world, I'd say that there's not one that makes vast sense over another. There are probably some that probably will fall out of favor, and we'll go into those in a second. But ultimately, what I'm saying here is that depending on the recipe or the construction methodology using mass timber, it's not like you choose a post and beam solution over a honeycomb solution and you get a silver bullet of cost saving. It doesn't work like that. So there are 4 common systems that are kind of recipes for how you put buildings together. The first one is a post beam and slab, which is kind of like an analogy to traditional construction. There's the honeycomb, which is where you use effectively CLT for walls and floors. There's the point supported, where you try and eliminate beams and just deal with columns and floors. And then there's some composite assemblies in which you combine products together to try and find an advantage in things like span, and reduction of floor depth. So post-beam and slab, look, the grounds is an example of this. It's trying to find a mix between load-bearing open spaces and bracing. And so I think that post-beam and slab is probably, from my perspective and what we're looking at, is probably the system to choose overall when you look at the cost, I guess the overall trade-offs between what the system allows for in a residential context I'm talking about. There's a honeycomb side of things, a honeycomb structure, pretty good for quite cellular floor plates like hotels and student accommodation, things like that. But I know on the call, lots of experience around this kind of structure in New Zealand, and we also know that there's some issues around things like connections and processing cuts and things like that as well. But still an appropriate typology, and this Adelaide Oval Hotel, which you may be aware of, is a nice example of that, of effectively a building constructed on the side of the Adelaide Oval, whilst the Adelaide Oval was in operation for a hotel, which is perfect use for this. Everybody knows about this one, Brock Commons. In some cases, it's a leading building in a lot of cases due to its height and due to what it tried to achieve. But we are seeing that the kind of the point supported approach is not quite as common from what we're seeing, but it still has its place. Key to this kind of system from what we're seeing is having really sensible connections, really easy connections, and also a very structured and sequenced way of bringing up your facade, of course. Just a note on some of the differences between the New Zealand situation and the US situation when it comes to floors. So we find that in the States, there's the incumbent system for flooring systems is to pour gypcrete. And so you'll find that in mass timber buildings, there's an acoustic layer, and then there's effectively a pouring of gypcrete to make up to increase mass for acoustic reasons, but also for fire reasons as well. So it's not something we see here too much, or at least I haven't seen the use of gypcrete being used as a floor substrate in NZ. But I guess the other reason that it's used is that in California and in other states, they use the International Building Code, and mass timber buildings are driven by what we call Type 4 buildings. So you have Type 4 A, B, and C buildings, and each of those is limited by area and height. But the one thing they have in common is that all main structural elements need a 2-hour fire rating. And so you're getting into that space in which you are trying to find the best balance between acoustic requirements, fire rating, and structural dimensions of the product. Then there are composite assemblies. So these are assemblies in which you create something like a rib deck or a closed panel or a floor cassette. The main reason you would do this is to achieve longer spans, primarily. You may also be under pressure for overall building height because of planning restrictions. So if you go to a composite floor, you might be able to get a thinner floor out of it. You can see this is Daiman house that Lendlease built a few years ago, which is operating a 9 by 9 meter grid. You have some very deep beam sections here, but then you can also have I guess a kind of a composite beam slab option, and obviously allowing for exposed surfaces. This is a very deliberate choice by the client to expose this, but Lendlease was under pressure in terms of planning height to bring that height down of the building down below a certain level. Nonetheless, a beautiful building, and for people involved in financing and investment of these buildings, it was heavily oversubscribed in terms of both investment and in terms of rental. And there are some future options that are developing. Lendlease has an Australian Research Council grant in which we partner up with universities like Monash and Melbourne University, University of Queensland, and so there's a study going on right now about low carbon long span floors, and so there's a lot of potential here. The key thing is that we need to balance off the value added potential of these kind of flooring systems against the labor that's required and the logistics costs that are associated with making these kind of panels. Because right now, no major CLT provider is able to offer a composite panel using, say, for example, ribs to increase the spanning capacity. But if anyone knows of somebody doing that, I'd be quite interested in finding out. So yeah, that'd be interesting to consider. So it's not a free lunch though, by any stretch of the imagination. Anybody who's worked in a mass timber building understands that we get into this area in which we have to balance trade-offs. We get into a real whack-a-mole situation in which we solve for something down here, something else pops up. And so in our work, we've identified around 14 major factors that go into an algorithm for choosing the best kind of system. And each of these factors can have different kind of effects. And so I talk about this in terms of procedural effects, asymmetric effects, and entangled effects. So procedural effects is where in the serial nature in which we make decisions, one choice here flows on to the next thing, which flows onto the next thing. And basically, if we're not careful, you start to get waste building up. So for example, you make a decision about spatial grids, that in turn creates deeper beams that then might be required if the spatial grid wasn't so long, which then creates building services issues in which you're starting to do things like punch holes through beams and increase processing costs and those kind of things. Then there are asymmetric effects. So this is where one thing here has an outlandish or a far bigger scale effect on something else. So for example, you see this all the time in which structural calculations to drive section sizes tip into areas in which they pop out of the standard size range for a manufacturer. You get into the need for either making the section size bigger and then trimming down the four sides of the glue lam to get back down to the structural size. So you're paying for waste. And sometimes, depending on where you are, if you're dealing with glue lam, the costs for block gluing can be exorbitant. Something like 100% or 50 to 100% increase over a cost of a standard size between a standard size and a block glue, depending on when you are, of course. And then there's what we call entangled effects. So this is kind of spooky action at a distance. So this is where factors are having a non-obvious relationship. And one thing that's an example of this is that I mentioned before in California, you have 3 different building types, type 4, A, B, and C buildings, which have height and area limitations. And once you look at the code and the reasons why that is the case, you find that basically it's driven out of the experience of the Chicago fire more than 100 years ago. And so it comes down to things like ladder heights. So you have these kind of embedded historical things that pop into code that then influence decision-making now. So these entangled effects are a bit harder to predict, but they do happen. And so I'm just going to pick up three of the factors that we typically deal with. So the first one is this relationship between acoustic and fire. As I mentioned, in the States where we do most of our work, there's a 2-hour fire rating for the main structure. What this means is that you either prescriptively, you either coat or cover everything in 2 layers of plasterboard, or you size the timber member up to account for char for 2 hours. And so on one hand, you're paying for more material, on the other hand, you're paying for more labor. Never mind, both of those situations don't do anything for your acoustic requirements. In the States, they have the same SDC IIC rating as we do. So typically, they're looking for a minimum of 50. They don't do field testing, but there's a requirement there for that kind of rating. So we all know we have to add things to mass timber to get it to perform correctly. And so it's in the adding and the combination of these kind of fire requirements acoustic requirements, that we start to get into a world of interesting and frustrating possibilities. And you can see on the right-hand side, this is the typical detail of Brock Commons. And I don't know about you, but that kind of gives me the chills when I look at the build-ups and the labor associated with that. We know from our work that purely in terms of structural response, that mass timber beats equivalent concrete every day of the week. It's cheaper, it is cheaper. But as soon as you have to bring mass timber up for a fire and acoustic requirements, the situation reverses. So we're trying to find a way in which that reversal is as minimized as possible, given the current kind of materials and processes that we've got to hand. As I mentioned before, in the States, the gypcrete is the primary way of dealing with this. And in fact, what sounds like a bit of an anathema of introducing like a wet topping inside a dry construction methodology is actually the most efficient way of doing it at this time. But I think we all know there's a global race to try and find the fix for this. And so, there'll be some way of solving the, or making more valuable the things we need to do to CLT to get that to stack better in terms of cost. So one for us is the seismic divide. So we know that the mass timber construction, modern mass timber construction primarily came out of Europe. When we look at the connectors, the proprietary connectors that are available for mass timber buildings, we find that a lot of them just simply don't respond to the kind of seismic requirements that are in New Zealand, the US, Japan, and other places. So there's quite a lot of interest right now in the connector space, and I know a lot of people are working on this. I'd suggest reaching out to Home Solutions, who have just completed some bringing a connector system to market with Lend-Lease. So that's something to look at. And lastly, moisture. I think I touched on this before, so I won't go into too much detail here. But all I'd say is in the 14 factor or the 14 factor model that we have, moisture is down the track somewhat. We all know that New Zealand is reasonably unique with respect to its treating all bits of timber effectively. This is not the case in other places. From my perspective, building science and building physics is the way to deal with moisture in buildings when it comes to mass timber. We also know that by far and away, most of the damage comes from effectively during construction phase. So we have to treat that very seriously, of course, but it is treatable. I've got a few more slides left to allow any time for questions, but I just want to touch on design for manufacture, assembly, and disassembly, and supply chain integration as basically critical for the successful rollout of mass timber systems. So the principles for mass timber is the first thing we need to do, as I mentioned before, is manage these trade-offs. And I'm sure a lot of us on the call would be familiar with this whack-a-mole situation that goes on, in which we are trying to solve for a certain aspect of building, and then discovering later on that that has some implications, for some other aspect. So from my perspective, it's about trade-off management. There is no perfect solution. It's just about the most perfect given the settings that you choose as the ones that you want to try and hit. The next one is that the physical to digital relationship. So one of the key drivers of mass timber uptake is the fact that you can get to a point in which the design information can drive manufacturing information. There's still a threshold there, which is quite hard to cross in terms of software and those kind of things, but that's being worked on now. That won't be so much of an issue in the future. But the idea that whatever you draw can effectively be processed during manufacture is something that's quite unique in terms of its precision, in terms of all those kind of things. And the other thing is to think about this in terms of product. So instead of the collective amnesia we have with respect to projects and thinking about projects as one-off discrete things, we need to start thinking about product thinking in terms of scale in terms of efficiency, in terms of basically learning from feedback loops and folding them into getting ever and ever better in terms of what we do. So if we are able to do design for manufacturing and disassembly correctly, there are some things that are facilitated by that. The first one is we can get into day one circularity. So by which I mean, as we are designing a building or designing a system, we are able to then attribute to that element, that specific element, a kind of a recipe for circularity over time. But what that means, if we're genuine about circularity, we have to understand that maybe that building element, that beam, needs to be basically disassembled at some point, which means we have to think about connections, which means that the idea of wet toppings, wet permanent toppings sitting on top of materials that could be reused potentially is not the way to go in the long term. The next one is deep data. So again, whilst we are attributing a circularity recipe for everything inside a building, we can also understand the embodied carbon, the carbon to manufacture, the carbon sequestered, and effectively the responsibility we have over the long-term life of the building to preserve that carbon and basically take ownership of that. And the other thing that's interesting is design automation. So I recommend having a look at Lend-Lease Podium's website, in which if you take a product thinking view, you're able to then effectively get into design automation, in which you move well beyond BIM into effectively a instantaneous instantiation of building systems down to LOD 400, 500 in terms of manufacturing in minutes rather than months. So once you have your product sorted out, your design methodology sorted out, everything associated with it, you're able to obviously record that data, have that data there, and effectively use algorithms and parametric processes to instantiate that building on the fly. Everybody who's an engineer or an architect or a designer on the call should really understand that automation is coming to design at a very, very rapid rate. Last slide is that 21st century buildings need 21st century processes. It's my view that that conventional design process is incompatible with 21st century buildings. So we need to radically rethink how we go about designing our buildings, designing our products and systems. So thinking about a product view, so that our clients who will want to use mass timber buildings are rewarded by the fact that we've created a system that they're able to use that has got basically the majority of their needs answered for in the product design itself. So this is one thing I'm working on, is a radically different design process, which borrows from other industries, but effectively aligns with the built environment, aligns with buildings, and means that we're able to rethink the typical contractual, milestone-driven, linear process we typically work with into a much more collapsed, much more integrated and collaborative way of buildings, and much faster as well. So I think the thing for me, just to summarize, is that mass timber is a great material. It has its constraints, it has its consequences, but it also allows for things that we haven't quite yet worked out are available to us. Should we follow these principles? Should we explore them deeply? So I think that's my last slide. Thank you.
Thank you very much, Daiman. A very interesting and thorough talk. I think you made all of your points very clear. And if I'm not wrong, there is one question just coming up now. Let me just open it. Just give me
Sure.
a moment. a question from Dr. Andy Buchanan telling us, is there any international consensus on how to balance the architect's design to see more wood and the fire engineers need to cover it all up?
Right.
Dr. Andy Buchanan.
Yep. Cool. Hi, Dr. Andy. Look, it's interesting. There's quite a few factors and forces in play right now. I mentioned before that in California, particularly, there's the current code, CPC code for Type 4 A, B, and C buildings is up for a revision to come out next year. And the key part of that revision is previously in Type C buildings, which are the smaller ones, you're able to expose 100% of the timber as of right. You still had to get that 2-hour fire rating. In Type 4B buildings, you're allowed to expose 20% of the timber as of right. And Type 4A buildings, you couldn't expose anything anywhere. The new revision allows you to expose 100% of the timber in Type 4B buildings as well, which from memory is buildings up to 12 levels high. So, so policy in California is driving towards more exposure. And really, in terms of the fire engineering side, with that policy support or that drive, it's starting to encourage more innovation in the way fire is dealt with in terms of exposure. I still say there's some issues around things like concealed spaces. And probably another big aspect that's coming in, not so much from the fire engineering side, is from the insurance side. So insurers are increasingly getting their heads around mass timber buildings. So I think policy is driving towards exposure. There's also a nice relationship there in which sizing for char allows you to have more timber in the building, which allows more carbon. And then really the problem then becomes solving for acoustics. So I think it is changing. It obviously does depend on you're a fire engineer. Yeah, what support you've got. I can shout out to Holmes Fire in the US for that one, where we primarily deal with these buildings.
Okay, thank you. Another question coming from James. Is there any push to use the CLT and other mass timber in residential design, and push to get these products accepted by building authorities?
Look, I think as most of my work is offshore now, I haven't had a great deal of experience over the last couple of years, but certainly when we were operating here, getting consent for the use of mass timber, I never had a problem with. I think probably a big part of that was a very collaborative approach and a very open approach to what we were trying to achieve. I think that probably the biggest issue for mass timber uptake in NZ is probably availability of the material, and probably we need to move from this constant piloting phase we have of testing out different kinds of constructive methodologies to try and find the one that works, and effectively just find a good solution that has the right trade-offs balanced and enables us to go into multi-residential timber. So I'm making it sound probably a lot simpler than it is, but once we understand mass timber in the context of the building system, we're able to go and then manage those trade-offs, particularly around things like passive fire, which up until recently was not particularly well understood. There are other things we can do as well around things like HMS coatings potentially, but it's really about trying to find the best fit for multi-residential that makes sense in terms of cost. We know it makes sense in terms of time, but it only makes sense in terms of time if you get the system correct. I'm very hopeful that that we'll be building more residential buildings using mass timber, and really there's nothing really stopping us from doing that.
Okay, now we have Hans Gerlich asking, we know that mass timber can achieve a high fire resistance rating depending on thickness, but the wood also adds fuel, which changes assumed fire characteristics. This is a current challenge. Is this a current challenge?
Yeah, look, I think I'm a generalist on the subject. You know, I'm not an engineer or a fire engineer, so I understand the point. The general understanding that we have is that after a certain point, then we do start to get charring and start to be able to get that protective layer going up. But I wouldn't want to get too much into the details now. I think it is a challenge, but it's probably a challenge that's being looked at by a number of people. I know a number of people in New Zealand are doing tests on these kind of things right now. I also know that we need to look at this holistically as well. So there are other factors that go into fires within residential buildings that are behavioral driven, that are spatially driven, that are driven by things that we might be able to have a bit better understanding of as well. But Hans, I think I'll defer to other people's expertise on that. Okay. Certainly, I think where policy is going is pretty deeply rooted in kind of the latest studies. There was a study done out of Sweden recently, which I might find a link to and recommend you go and have a look at.
Okay, another question is telling the design process in New Zealand seems to be quite traditional and non-automated generally. Considering your experience in California and working in close proximity with Google and Silicon Valley, does the US approach seem to be much different? How do you suggest New Zealand engineers improve their digital skills and facilitate the design automation process?
Yeah, when you step back and think about design process in this country, you realize how archaic it is. But the good news is that it's archaic pretty much everywhere as well. So it's not like we are lagging behind in the way we design. Yes, there's a lot of entrepreneurship and a lot of startups in the US. But really it's still nascent. So I think the cool thing about that is we do have a chance to get in front of this and get in front of design automation quickly and to be able to nimbly take it up. So look, I'd say, when we and I have a very a lot of experience of dealing with local authorities in California, but in some ways it's much harder over there. In Silicon Valley, where Google's land is, there are 4 different cities that you have to deal with. And each city has a different interpretation of code. Each city has a different fire marshal. They have different attitudes. So in New Zealand, let's say in Auckland, under a super city, hopefully much more coordination and much more of a one message that can be taken up. So in terms of things like compliance, it's probably easy to have a conversation with people. My recommendation to the engineers and architects and everybody else on the call is there is a massive precipice between young architecture and young engineering graduates and practice. Most of the architecture graduates are, well, a lot of the architecture graduates are getting into and being very, very deeply informed of computational design, parametric design. Unfortunately, they then go into practice and basically start designing bathrooms and very traditionally. So there's a latent workforce out there that's young, that knows the stuff, that you're able to access basically. Just lastly, companies to go and look at: Archistar is one, Test Fit is another one, CAD Makers out of Vancouver is another one to look at. There are other companies, Giraffe, Hyper. There are a few startups you can go and look at, see what they do. Most of the time, what they're doing right now is dealing with planning. They're able to instantiate buildings and respond to planning restrictions, primarily using geometry. The next step is obviously is to bring in the actual products, and that's basically what Lendlease is doing. Is not just design automation to respond to planning requirements, but design automation with LOD 500 manufacturing drawings to basically really get to that space. So really exciting, and yeah, the big takeaway today is go and look at design automation, computational design, and get behind it.
Daiman, I think that's the last question that we have at the moment in our list. So we would like to thank you once again very much for your time and effort to prepare this nice and thorough presentation. Well done, and we look forward to see you once again in the future in TDS webinars. And at the same time, everybody would like to say thank you for attending this afternoon, and hopefully we'll see you on the 26th of May in the next webinar. Have a lovely and good afternoon.